Okay, hello everyone. Hi, good afternoon, and I welcome you all to the platform of Sri Chaitanya. My name is Shubhojit, everyone, and as I believe I have taken 2 or 3 sessions in this particular platform, so you might be knowing me that I take care of physics. So today we will be taking care of the chapter that is known as electricity. Okay, so in our electricity particularly chapter, this is one of the important chapter for the grade 10, with respect to the boards also, and with respect to the with respect to the score exam also. In our today's session, we'll be taking care of the concept of the electricity. Obviously, when we talk about the concept of the electricity, it is very detailed, very detailed. Okay, if you try to understand the electricity in a very detailed manner, you will be very much fascinated. Okay, so it will be very much fascinated that how it is happening, how every single thing is happening, how the electrons are moving, why the electrons are not moving in accelerated motion, or it is moving in accelerated motion, how we can get to know it is moving in accelerated motion and all. Getting my point? Why we are taking consideration whether the charges are moving in uniform motion and all. Fine. So it is very much fascinating. But as you all know, this is time constrained, everyone. Okay, so we have to take care of the important topics itself. We won't be getting into the very detailed manner. We will be getting into the what is important to you, how we are getting the questions, how we are going to solve the questions. Okay. Now, as this entire series is concerned, it is for the preparation of your score examination, as you all people know. So in this particular series, whatever the question that we are going to do in this particular session, I am not saying that it will be that all the questions will be coming from this only, but what I am saying is this will be the type of the question, this will be the standard of the question. It may be little bit more, it is not going to be less, it is going to be more only. Fine. So I have done my best. I'm not saying I'm done my best, but I have tried to give you all the information required in this. There are few of the information that I will be writing over here also, but I will be teaching you in my best capacity. Okay. So when we talk about the electricity, everyone, what is important about this particular chapter? What is important? See, if you try to define the electricity, we have to define the electricity in a very general way. And we define the electricity in a very general way. What is the definition of electricity that we generally define? That is a source of energy. That is fine. It is a source of energy by which we are capable of running all the electric appliances. It may be a small mixer, it may be a very big machine, whatever it is. Okay. So electricity is a source of energy by which we are able to run the entire electronic gadgets, electronic device, whatever it is. Okay. But in electricity, what actually makes this entire chapter very much big? Why this particular chapter is very much interesting? Because of when we talk about the electricity, everyone, okay, there is 2 things that we have to understand first. Then only after little bit of more conditions, little bit of more experiment, we will be expanding this entire electricity chapter. The only one thing that is the curiosity of making this particular chapter is how the electricity is generating. It is a form of energy, right? So how it is developing, how it is creating, who is creating this electricity? Getting my point? And you might be saying, sir, this is energy, how it is being created? No, it is not been created, but why we are talking about it as a source of energy? How it is a source of energy? That is what the question is. Getting my point? How it has been created, how the source of energy is there, why we are talking about electricity as a source of energy. So to understand the electricity, we have to understand electric current. Okay, and when we are talking about the electric current, we have to understand about the electric charges. That is very much important. Getting my point? So let me remind you a little bit of chemistry over here. Little bit of chemistry, nothing more. Okay, I believe you might have heard about the chapter in grade 9 chemistry that is known as atomic structure. Okay, in the atomic structure, you have learned more about the atoms and all. Okay, if you try to define the atom part, like every single substance, every single matter is made up of matter. You can every single thing is made up of atoms, as you can say. If you try to define the matter, if I'm not wrong, you can say that the atom is the smallest particle of any of the matter. It's the smallest particle, and it cannot be further divided. This is what we have learned in first and second chapter of the chemistry, everyone, of grade 9. But when we move to that particular chapter, which is the last chapter of grade 9 chemistry, that is the atomic structure, the very first line it is written as ki earlier we believed that the atom is going to be atom is the very smallest particle and it cannot be further divided, but which is wrong. We have found out that atom can be also further divided, and it is divided into subatomic particles. Getting my point? If you remember that particular part, you have learned that subatomic particles are proton, electron, and neutron. Simple words. Okay, so let me help you out to understand the entire thing by a few of the things. What is our motto over here is, our motto will be to understand, our motto will be over here to understand every single thing about the charges first, then we'll try to move anything else. I'm extremely sorry for this. Okay, just allow me a second, please, people. Fine. Okay. So when we talk about the atoms, everyone, we all have remembered that particular atom, what is atom and every single thing. Okay, how we can define the atom, basically. If we talk about the atoms, is the smallest particle that we have learned, but further we have learned no, it is also divided. How it is divided? It is divided into subatomic particles. Subatomic particles. If you try to remember your grade 9 chemistry, you can understand the subatomic particles are nothing but the proton, the electron, and the neutron. Simples. Proton, electron, and neutron. Now, if you have gone through that particular chapter, you have learned that we have done a lot of experiment to understand that this is new for us, na? Atoms is divided, we have found out subatomic particles, so it is very new. What is proton, what is electron, what is neutron? Then we have found out that this electron, proton, and neutron are nothing but they are possessed with charges. They are possessed with charges, everyone. These are charges, basically. These are charges. Getting my point? These are what? Charges. Fine, no problem, we have understood this much also. Now, one more information, since we have to complete the entire thing in a very detailed manner, everyone, so there are a lot of things that I will be writing then and there only, because I believe you have gone through this particular chapter. Okay, so when we talk about the charges, everyone, the charges, one charge is represented by small q. Please do remember this. One charge is represented by small q. I hope you have understood this much. Now we will be talking about lot of this. Okay, do not worry. There are a lot of things that we have to talk about this particular chapter. So when we talk about the proton, electron, and neutron, we have found out that these are charges. When these are charges, one charge is represented, whether we are talking about proton or electron, it is represented by small q. And this is what charge is all about. After a lot of experiment, we have found out that okay, so proton is a positive charge. We have understood that the proton is possessed with the positive charges, whereas the electron is possessed with the negative charges. Including with this, when we have reached to the neutron, everyone, we have found out that it doesn't have any charges. It is completely neutral. It doesn't have any of the charges. It is completely neutral. Okay, if it is completely neutral, okay, if it is completely neutral, that we have found out. Fine, no problem, fine, no problem. We have understood this much. Okay, so that the proton is positively charged, electron is negatively charged, and Ns, that is the neutron, is completely neutral. Very good, no problem in that. After understanding this, we have a curiosity of understanding. What do we have curiosity of? How the smallest particle, that is atom, everyone, have these three subatomic particles, proton, electron, and neutron, arranged. We want to find out that arrangement. So if you have an understanding of this, okay, so you might have learned about this, that in any of the atom, the central part is there. In any of the atom, there is a central part. In the central part, we have the positive and the neutral one, positive, neutral, positive, neutral, positive, neutral, positive, neutral, positive, neutral. So the center part of the atom is completely filled with positive and the neutral charges, where these positive and the neutral charges are completely combined together, okay, and they are forced to not move. They are not moving anywhere. They are completely fixed. How they are fixed? They are fixed with the strong nucleus force. This particular centerpiece of the atom is called as nucleus. centerpiece is called as the nucleus, everyone. Simple, है ना? And after that, so this is neutron, this is positive, this is neutron. What about the negative charges? Fantastic. The negative charges is very much allowed to move in the outer orbits. The negative charges are very much allowed to move in outer orbits, everyone. Very much allowed to move in outer orbits. Fine. So here, if you can say, these are electrons, everyone. These are electrons. Simple. They are allowed to move forward. They will be moving forward. Okay. These are the only charges which are allowed to move. Simple. And the arrangement is a little bit here and there, but this is what it is there. Fine. Whereas these dotted circle lines are called as orbit. This is nucleus, and this is entire arrangement of the atom. This is what it is there, everyone. Fine, we have found out this much. After this, there was a curiosity. There was a curiosity ki, acha, this is all about the chemistry. What we are going to learn about in the terms of physics. What we are going to learn in the terms of physics. What we are going to learn in the terms of physics is, we'll try to understand the property of the charges. Okay, we have to try to understand the properties of the charges. So the first thing that is coming in our mind is ki, acha, suppose ki it is positive charge. What is the magnitude? What is that numerical value? What is that numerical value of one proton or one electron? What is that numerical value? So the value of one proton is equals to 1.6 into 10 to the power, sorry, it is going to be 1.6 into 10 to the power minus 19. So minus 19 what? It is a charge. So what is the SI unit of charge? The SI unit of charge is coulomb, which is represented by C. Okay, capital C. Similarly, if we talk about one electron is also 1.6 into 10 to the power minus 19 coulomb. Simple and straight. This is what it is there. Now, suppose that if I have written somewhere it is 1.6 into 10 to the power minus 19 coulomb, and there might be a confusion. What is that confusion? Confusion may be that what charges we are talking about, whether we are talking about the positive charges or whether we are talking about the negative charges. So for that, to remove that particular confusion, we have come across with one representation. What is that representation is all about? That it is just for representation, it is not used in numericals, everyone. For proton we put positive sign, and for electron we put negative sign. It is just for the representation. It doesn't involve anything in the numericals, everyone. Please do remember this much. It doesn't involve anything in the numericals. It is just for the representation for positive and negative. This is the value. Okay. Now, although what do we say? This is the value of one electron, one proton, and this is what it is there. Now, we have jumped into the properties, because when we talk about the physics, we need the properties, everyone. Properties of charges. Okay, properties of charges. Please do remember, everyone. One question may be asked. If we talk about the charges which is represented by Q, which type of quantity it is, whether it is a scalar quantity or whether it is a vector quantity, so please do remember it is a scalar quantity, everyone. It is a scalar quantity. It is a scalar quantity. What is the SI unit of charges? That is coulomb, represented by C. Simple. When we talk about the properties of charges, everyone, there are few properties that you already know. What are that few properties? Suppose that if there is a charge which is represented by positive and positive, everyone, so it will be considered as what? If we talk about the charges, it is considered as positive and positive. So it will be what? It is going to repel each other. The repulsion will be there. If it is a repulsion, everyone, or you can say if we talk about the negative and the negative charges, again the same thing will be there. It will be repulsion. This is called as like charges. This is called as like charges, people. If it is called as like charges, the like charges always repel. Repels. Like charges always repels. If we talk about the unlike charges, in sense, like for an example, like suppose that we have having one of the charge which is positive, one of the charge which is negative, or one of the charge which is negative, another charge is positive. In both the cases, what will be happening? They will be attracting each other. They will be attracting each other. This form is called as unlike charges. This form is called as unlike charges, and when we talk about unlike charges, the unlike charges attracts. the unlike charges attract. Simple. These are the few properties of the charges that we have to come across with. Okay, this is going to be very helpful because there are small questions that may be asked from this particular concepts. Okay, we are having few more concepts, everyone, that we wanted to understand. What are the concept that we are going to understand is few more properties are there. Few more properties will be there. Okay, and we will be talking about that also. Okay, so this is one of the property like charges and unlike charges. Let us move to the another properties, everyone. Let us move to the another properties. If we talk about the another properties, people, if we talk about the another properties, we can talk about one thing. Suppose that there is an element. If I talk about that, if I say that the number of protons, just an example, everyone, the number of protons are 17 and the number of electrons are also 17. Getting my point? If I ask you that what is the overall charge on this particular element, what you will say? That, sir, number of electron is same equals to number of proton. So I can say the number of positive charges and number of negative charges are same. So this particular body will be completely neutral. No doubt in this, it is completely neutral. Okay, but what if people, if I there is a chemical reaction takes place, and what if that we have lose one electron? What if we have lost one electron? In that particular case, if we have lost one electron, then it will be counted as 16. So the number of proton will be increases with respect to number of electrons. So it will be behaving as positive. Okay, it will be behaving as positive. Similarly, if we try to gain one electron, in the same condition, if we try to gain one electron, in that particular case, it is now going to be 18. So number of electrons will be increases. So this entire element will be behaving as negative, everyone. So please try to remember, everyone, कि whenever if we are losing one electron, the element will behave as positive. If we are gaining one electron, it will be behaving as negative. This is also one of the properties. Okay, this is also one of the properties. So if it is so, after that, the very important properties that we are going to talk about, it is called as quantization of charges. What do you mean by quantization of charges? Quantization of charges means the amount of total charges which is there in that particular element or matter, whatever you can say. Fine. So quantization of charges, you can think about it. Ki in that particular atom, in that particular amount of material, there is no any one electron, na? There is no any one proton. There will be millions and billions of electrons and the protons will be there. Getting my point? How to find out the total number of charges? So the total number of charges will be found out by the formula. The quantization of charges refers to the total charge. Total charge is represented by capital Q. Capital Q will be NQ, everyone. That is NQ. Whereas this Q is represented as total charge. Whereas this particular small q represented as charge. Whether we are talking about charge, whether we are talking about electron or we are talking about proton, we wanted to know. And this n is the number of charges. Number of charge. How many charges are there? How many protons are there? How many electrons are there? And there is one particular thing that you have to remember about this, that in this particular case, the n will be 1, 2, 3. It cannot be fraction, it cannot be decimal, it cannot be, okay, it should be 1, 2, 3, 4. We have to count that. It cannot be fraction or decimal. Okay, so this is what it is entirely there. Now everyone try to understand, if we are talking about the charges, total number of charges, that is Q equals to NQ everyone, and where charges is negative and positive, there is electron and proton. We all know, what we know, that the proton is completely fixed in the nucleus, it cannot move. Only one charge is allowed to move, and that charge is called as what? That charge is called as the charge is called as what? The charge is called as the electron. When we talk about the charges which are following with the charges which is allowed to move, which is allowed to transfer, that is the electron. So this entire thing, this is a general equation, this entire thing will be refers to as Q will be equals to Ne minus. Okay, this entire equation will be refers to as Q equals to Ne minus. Simple. Okay, whereas this, the value of E will be equals to 1.6 into 10 to the power minus 19 coulomb. We are talking about the value of one charge. This is the number of charges, 1, 2, 3, 4, whatever, and this is the total amount of charge. Getting my point? We are talking about the electron. Simple. This is what it is there. So there is a very famous question that has been asked everyone. Okay, so I'm going to, this is not famous, but it is a very simple question to ask. Ki, tell me, if we are having the total number of charges which is 1 coulomb, let us say, and the total number of charges is 1 coulomb, let me know the number of electrons, which is required to produce 1 coulomb of charges. This is what we wanted to know. Okay, this is what we wanted to know. Let me help you out with this one time more. So basically the question is like this. If the question says, if the question is saying everyone that the total number of charges is 1 coulomb, we want to find out the number of charges, which is the number of charges required to produce 1 coulomb of charge. Getting my point? So as we all people know that the proton is not allowed to move, only electron is allowed to move. Okay, so what we can write, we can go with the formula. What we can go, that the Q is equals to Ne everyone, where the value of Q is equals to 1, the value of N that we have to find, the value of E is 1.6 into 10 to the power minus 19 people. Coulomb. If it is so, the value of N can be represented as 1 by 1.6 into 10 to the power minus 19. If it is so, we can calculate it. What we can do is, the value of N can be written as 1 into 10 to the power 19 divided by 1.6. If you try to divide it down, so you will be getting an answer of N will be equals to 0.625 into 10 to the power minus 10 to the power 19. 19 what? These are the number of charges. 0.625 into 10 to the power 19 charges will be there. Which charge? Electron will be there. Okay, good evening everyone. This will be there. Or it can be written as N will be equals to 6.25 into 10 to the power 18 everyone. 10 to the power 18. It will be produced. This much amount of, these much charges are required to produce 1 coulomb of, this much electron is required to produce 1 coulomb of charge. To produce 1 coulomb of charge. That is your answer. Okay. If it is so everyone, if it is done, after that when we talk about this much property which is required and this much concept we required, after that we have got an understanding that, oh, these are the things that is moving and electron is moving and it is creating. That is what it is there. So we have increased our curiosity and we wanted to know, if the electron is moving, then what does it create? Getting my point? If we want to know that if the electron is moving, what does it create? Then after we have done a lot of different experiments and we have come across ki if the number of electrons are moving per unit time, the number of electrons are moving per unit time in a conductor everyone. I believe the conductor you people know, hai na? So I'm not going very in these things because you know this, what is conductor, what is insulators. Okay, so we are just going with the basic understanding of this. So we have found out, we wanted to know if the number of charges, total number of charges is flowing through a conductor per unit time, okay, what does it create? It It creates electric current, everyone. What does it create? It creates electric current, which is represented by I, which can be also written as Ne minus T. This is current, everyone. Fine. If you want to go with the electric current, there are few points that we want to write it down. If we talk about the current, it is the SI unit of current is known as what? Ampere. Ampere, which is represented as capital A. Simple. When we talk about which type of quantity it is, so please do remember that it is a scalar quantity. Simple. It is a scalar quantity. I believe it is not very much visible to you. Let me write it in a very different color. Okay. If we talk about the SI unit, everyone, SI unit of current, it is represented as ampere, which is capital A. If we talk about the which type of quantity it is, so it is a scalar quantity. It is a scalar quantity. Fine. Moving next, if it is a scalar quantity, we have found out the formula. Few more things. There is a device, everyone, a device which is used to measure the electric current. The device which is used to measure the electric current, it is called as ammeter, and it is ammeter and is connected in series. It is connected in series. Please do remember this. It is connected in series combination. Fine. It is connected in the series combination. This is what it is there. I hope this much is clear to you and you have understood this much. Okay. If it is so, after understanding about the electric, after understanding about this current, that is Q equals to Q by T equals to Ne minus T, and this is all about the combination and all, then we want to find out few more things. What we want to find out is, we have done a lot of experiment, and then there was a scientist known as Ohms who has come across with a particular understanding. Okay, see, if we are talking about the conductors, this is all about the conductors only, because the charges are allowed to move in the conductor, so we are talking about the conductors only. So Ohm's law is given according to the conductor. It has been said that at a constant temperature, if the charges are flowing through a conductor, okay, if the charges are flowing through a conductor, what will be happening? That the potential difference will be equals to what? Potential difference will be equals to the current. Not equals to, directly proportional to the current, everyone. This is what it is there. Fine. Now there is one more topic that I have left, so that is what I am going to teach you right now. If we talk about the potential difference, everyone, potential difference. If we talk about the potential difference, we all people know potential difference means what? That the difference between the 2 points of a particular wire. Okay, so we can say the potential difference VA minus VB can be written as change in potential difference will be equals to difference in potential difference. This is difference means subtraction, everyone, which can be written as the work done moving that particular charge from one point to another. Okay, charge, everyone. If we talk about the potential difference, everyone, the SI unit is going to be voltage. Sorry, it is going to be volt, which is represented as V. Right. This is the potential difference. The difference between the 2 points of a particular wire, okay, it is equals to work by charges, everyone, and the SI unit is volt. Fine. SI unit is volt. Few more things about this. What we can say, everyone. Sorry. What we can say about this? Few more points. That the potential difference. If we talk about the potential difference, everyone, so it is measured, it is calculated by the device known as Measured by what? Measured by voltmeter. Voltmeter. And is connected in parallel, everyone. In parallel. In parallel combination. This much which is required. Potential difference. Fine. If the potential difference and the current is very much clear, okay, so we have talked about the Ohm's also. Ohm's law, everyone. So Ohm's law is given for the conductors. Okay. Ohm's law is given for the conductors. A conductor which is following the Ohm's law is given for the conductors. Okay. The conductors which obeys the conductor, it is given by the it is given for the conductors which obeys Ohm's law. Ohm's law, and which is also called as ohmic conductors. The law is given for the conductors, which type of conductors? The conductor which obeys the Ohm's law, which are also called as ohmic conductors. Okay. Ohmic conductors, everyone. And there will be an exception, that is non-ohmic conductors, okay, like transistor, transmitter, okay, vacuum tube. These are the entirely non-ohmic conductor, but we don't have to remember this, but this is what it is there. The Ohm's law is given for the conductors which obeys the Ohm's law. Okay, conductors which obeys the Ohm's law, these are called as the ohmic conductor. And it is saying, please do remember, at constant temperature, for a given experiment, the temperature should be constant. At constant temperature, everyone, we have found out the potential difference should be directly proportional to the current. This is what it is there. It is what is being said by the Ohm's law, that at the constant temperature, potential difference is directly proportional to the current. But we are talking about a conductor, and when we talk about the conductor, it can be of any material or something like that. Okay, for an example, like if we talk about a conductor, let us for an example, copper is a very good conductor with respect to aluminum. But how aluminum is a bad conductor? It can also, the charges can also flow through it, okay? So how it is bad or how it is weak, how we are comparing this? So we are comparing that, suppose that there are 10 electrons which are trying to move in copper. So copper can allow 9 electrons to move. That is why it is good. If we talk about aluminum can allow only 5 or 6 or 4 electron to move. Now the question arises, who is stopping that 4 electron? Who is stopping that 1 electron? Who is basically trying to resist or trying to stop the charges to flow through them for a given conductor? So this directly proportionality, if you remove it, it will be going to be IR, everyone. Whereas this is a constant for a conductor. It is a constant, everyone, and this constant is called as resistance. The constant is called as resistance, everyone. Simple. The constant is called as resistance. Fine. Now what you have to remember is, you have to remember this formula, V equals to IR. Okay, so where R is the constant and it is called as the resistance, people. When we talk about the resistance, people, we are talking about the resistance for a conductor. Getting my point? We are talking about the resistance for a conductor. If, as you can see over here, we can say from the Ohm's law, we can write what? That the R will be equals to V by I. That means if the resistance increases, the current will be less. If the current increases, the resistance will be less. Okay, this is inversely proportional to it. This is one of the formulas for finding out the resistance. The another formula for finding out the resistance lies in the factors affecting the resistance. Factor affecting the resistance, everyone. Factor affecting the resistance. So what are the factors that is affecting the resistance? The first is R will be increasing according to the length. If the length increases, resistance will be also increased. R will be inversely proportional to area of cross section, everyone. What do you mean by area of cross section? Generally we are talking about the wire, okay? So this is called as area of cross section. How much thick it is, that is area of cross section. Fine. If you try to merge this entire equation, we can say R is directly proportional to the length of the wire divided length of the conductor divided by area of cross section of the conductor. To remove the directly proportionality, we have said R is equals to rho L by AS, that is area of cross section. What is this symbol? Whereas this is called as, this is resistivity. This is resistivity of a material. Please do remember this. है ना? Resistivity of the material, people. I hope it is clear to all. Now this is the another formula for the resistance. This is the another formula for the resistance, people. Please do remember this. There are few more things that you have to understand about the resistance first. What are those few things? If you try to understand, and if you talk about the SI unit of resistance, if you can see, it is V volt by ampere, which can be written as ohm. Okay, which is written as ohm. The symbol, the representation of ohm is like a headphone, like this. Okay, it is like a headphone like this. This is what it is there. Moving next, what else we can talk about this? Please do remember that resistance is directly proportional to the temperature. If the temperature increases, the resistance will be also increasing. Resistance is directly proportional. Resistance is directly proportional to temperature. Okay, the resistance is directly proportional to temperature, people. Please do remember this. Okay, but for when we talk about these few things over here, okay, please try to understand over here is that this is for the conductors. Okay. If we talk about the conductors, when we talk about the conductors, we can say that if the temperature increases, the resistance increases. But if we talk about the semiconductors, everyone, it is for the conductors. If we talk about the semiconductors, R is inversely proportional to temperature. You have to remember this. Semiconductors, everyone. Conductors. Okay, that is semiconductors, people. Okay, if we increase the temperature, the resistance will be decreasing. Now let us talk about the resistivity. Resistivity, everyone. So the formula for finding out the resistivity is, resistance area of cross section divided by length. If we talk about the SI unit of the resistivity, it is very simple. It is going to be ohm. It is going to be ohm meter. It is going to be ohm meter, everyone. Simple. It is going to be ohm meter. Fine. So this is what the resistivity is all about. This is what resistivity is all about. If anyone wants to understand that what will be the representation in the form of a graph, please do remember this. If we talk about the form of a graph, it is like this. It is going to be V, it is going to be this, and this thing theta, that slope is giving you the idea about resistance. This is the slope, and the slope will be giving you the idea about the resistance, everyone. Simple. Okay, moving next, there are few things. Okay, what are the few things? If we talk about the let us, if we talk about conductance, resistance is there, the conductance will be there, the reciprocal of resistance will be conductance, reciprocal of resistivity is conductivity. These are the few things. After that, we are going to talk about heat, everyone, which is also called as Joule's law. Okay, which is also called as Joule's law. Joule's law. Fine. It is also called as Joule's law. So in Joule's law, it has been said that what has the Joule's law said? It is very simple, that the heat which is being transferred, that whenever the current is passing through a conductor for a particular few times, okay, for certain time period, okay, it will be creating the heating effect. It will be creating the heating effect. That is what it has been said. It will be creating the heating effect. It is what it has been said. Fine. That is called as the Joule's law, everyone. It is called as the Joule's law. If it is clear to you, now let us move to the mathematical representation of the Joule's law. To the mathematical representation of the Joule's law. That is very much important. Fine. So when we talk about the H is directly proportional to the current square. H is directly proportional to the resistance. More resistance, more temperature will be there, and H is directly proportional to the time. If you try to join this thing, it will be written as H will be equals to I square R T. That is one of the formulas. Okay, this is one of the formulas. If we talk about the SI unit of this is what? This is heat. And or you can say energy, and the SI unit of energy will be equals to Joule. Sorry, SI unit of energy will be Joule, which is represented as J. Simple. Fine. It is so. Now you can reverse this thing and you can find out the different formulas of the heats. Okay. After this particular thing, what else we can talk about? We can talk about the power, people. We can talk about the power. If we talk about the power is very simple, that the power will be equals to, either you can say the heat, either you can say the work done divided by the time, or you can say the heat energy transfer divided by the time. In any particular instant, it will be equals to, the power will be equals to V into I into T divided by T. This T and T's cancel, which will be equals to V into I. If V into I you have found out, then you can find out from the Ohm's law. Okay. From the Ohm's law, everyone, from the Ohm's law, what are the things that you can go with this? That the power, as you can say, it is V into I. From the Ohm's law, it is, we know now V equals to IR. If V is equals to IR, you can put the values over here. Okay, so you can write it out that if we put the IR over here, it is going to be I square R, or P can be written as V square by R. Okay, so what is the SI unit of power? SI unit of power, the SI unit of power will be equals to what? Which is represented as, SI unit of power is basically Joule per second, which is written as what? And it is represented as capital W. Okay, what is a very small unit? What is a very small unit? That is why we have to convert this into kilowatt. Kilowatt or megawatt or whatever. So kilowatt is 10 to the power 3 watt. Simply. This is what it has been done. After that, we have to understand the commercial unit of energy, everyone, of electricity, whatever that you can say. The commercial unit of energy, you can say that the bill that we are talking about in our home, the bill is coming out into 1 kilowatt with respect to every single 1 hour. So 1 kilowatt hour, if we have to convert this into Joule, okay, so it will be 3.6 into 10 to the power 6 Joule. Please do remember this. This is the conversion, everyone. Okay, this is the conversion. This is what it is there. If you try to do this thing, it will be more than enough. Okay, this is what the entire electricity is all about. If I have missed one thing, that is going to be parallel and series, everyone. If we talk about the series combination, if we talk about the series combination, everyone, if the resistance are attached one after another, then it is considered to be known as in series combination. For this series combination, we always have to find out the R equivalent. R equivalent will be equals to R1 plus R2. Please do remember this. If we talk about parallel combination, everyone, if we talk about parallel combination, parallel combination is like when the branches are there. When the branches will be there, which are connected to a battery. This is R1, this is R2. Fine. So R equivalent will be represented as 1 by R equivalent will be equals to 1 by R1 plus 1 by R2. In a simple form, you can write it down. R equivalent can be written as, for this parallel combination, it is R1 R2 by R1 plus R2. Few more things, everyone. In series combination, current is constant, I is constant for the circuit, V is variable, for every single resistor. If we talk about the parallel combination in this, if you try to understand in this, so try to understand V is constant, potential difference is the constant for this, I is variable for each resistors. These are the topics. That's it. If you try to understand this entire thing, okay, it will be more than enough, and you can find out the entire answer for this. Okay, now this is the entire presentation. If you can go with this, you can have an understanding of that also. It is written all over here. Okay, so there are few questions that is for you to solve and you to understand. Okay, so let us meet in the next session, and do not forget to register on this examination, everyone. Okay, so this is all for the day. Please do like the channel, like, comment, share and subscribe, everyone. This is all for the day, and do us follow on the Instagram, do subscribe the YouTube channel, and you can find out the PPT of this particular session in Telegram. Okay, this is what it is all about. So thank you everyone for joining the session. I hope I have taught you entire thing about the electricity. If you have any concern, any comment, any question that is coming in your mind, you can ask me on the comment section. Till then, thank you everyone for joining. Bye everyone, see you all, and have a nice day. Thank you.